I welcome all of you for the discussion of applications of PDE. So in this video, we are going to discuss about the solution of heat equation. So ಎಲ್ಲರಿಗೂ ಸ್ವಾಗತ ಈ ವಿಡಿಯೋದಲ್ಲಿ ಅಂಡರ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ PDE ನಾವು heat equation ಸೊಲ್ಯೂಷನ್ಸ್ ಅನ್ನು ಹೇಗೆ ಕಂಡುಹಿಡಿಯೋದು ಅನ್ನೋದ್ರ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಸೊ heat equation ಇಲ್ಲಿ ಬರ್ತಿರೋ ಹಾಗೆ dou u by dou t is equal to c square into dou square u by dou x square. So this represents heat equation. So what is heat equation? Let us look into that. The heat equation, it is an important partial differential equation which describes the distribution of heat or variation in temperature in a given region over a time. See, this actually predicts that if a hot body, if any hot body, if it is placed in a box of cold water, then how the temperature of the body will decrease, and eventually the temperature of the body, the temperature of the body that is kept in the box, that will equalize the temperature of the box, right? So if you can look into this diagram here, the portion having red color as maximum temperature, that will be decreased to lower temperature after some particular time. So that temperature distribution is described by heat equation, and this was derived from Fourier's law, and conservation of energy by Cannon in 1984. Now, okay, let us look into the solution of heat equation. As usual, we have to start with the given equation. Solution: given dou u by dou t equal to c square into dou square u by dou x square. Given dou u by dou t equal to c square into dou square u by dou x square. That is the given equation. You have to start with the given equation. Since we are applying separation of variables, we have to assume dependent variable as a product of independent variables, isn't it? So put u equal to capital X into t, where capital X stands for small x of capital X of small x, and capital T stands for capital T of small t. So capital X and T are functions of small x and small t respectively. So these are functions of single variable. You have to keep that in mind. So substituting this here, we get then the above equation will be dou by dou t of capital Xt is equal to c square into dou square by dou x square of capital Xt. Right, how to differentiate it? Now, partial derivative of xt with respect to t. So in that process, capital X will be treated as constant. So constant into derivative of capital T with respect to small t. But small t is the only one independent variable. So instead of dou, you can write d. So dt, d capital T by d small t equal to c square into the same procedure here. So t into it will be d square x by dx square. D square capital X by d small x square. Now we have to separate the variables. We have to collect terms in x one side and terms in y another side, and keep in mind that always try to get the constant in the denominator, right? So that we have to divide equation, both sides of the equation, by c square tx. So that will give you 1 by c square into 1 by t into dt by d small t equal to c square t get cancelled, 1 by x into d square x by dx square. You have to call the common value as k. Okay. Now you have to consider them pairwise. So considering pairwise, we get 1 by c square into 1 by t dt by d small t equal to k, and this side d square x 1 by x into d square capital X into d small x square equal to k. Now this will be d capital T by d small t equal to k c square into t, and here d square capital X by d small x square equal to k capital X. Okay, now this will become d capital T by d small t minus kc square t equal to 0. Another side is, so d square capital X by d small x square minus kx equal to 0. So that if you assume capital D stands for d by dt in this, then it takes the form dt minus kc square t equal to 0. So from that you can write d minus kc square times t equal to 0. D minus k c square into t equal to 0. Parallelly, here if you assume d to be d by dx, then we will get d square x minus kx equal to 0. So from that we can write d square minus k into x equal to 0. D square minus k into x equal to 0. Now we have to consider various possible cases. So case 1, assume k equal to 0. Case 1, assume k equal to 0. So assuming k 0, here you get, see, d into t equal to 0. From that auxiliary equation is m equal to 0. You get only one root. So obviously capital T will be C1 into e power first root into t. So I get t equal to C1. T equal to C1. If you come to this side, it will be d square minus k. Oh, I am assuming k is 0, right? So d square capital X equal to 0. So auxiliary equation is m square equal to 0. That implies m equal to 0 comma 0. So you get capital X equal to C1. Okay, C1 we have already used. Okay, C2 into e power 0 into x plus, since we have repetition of root, x into C3 e power 0 into x. So you get capital X to be C2 plus x C3. So the required solution is u equal to C1 times C2 plus x C3. So this is the required solution when k is 0. Now if you assume k positive, case 2, if you assume k greater than 0, then we may assume k to be square of some number. Obviously p you can take root k. Definitely root k exists. So in that case the equation becomes d minus p square c square times t equal to 0, and here d square minus p square into x equal to 0. Right, now this will be okay. If I write the auxiliary equation, m minus p square c square equal to 0. So m equal to p square c square, and this side will be having m square minus p square equal to 0. So m equal to plus or minus p. Now the solution is capital T equal to C1 e power p square c square t, and this side capital X equal to c2 e power px plus c3 e power minus px. The required solution is u equal to c1 e power p square c square t into c2 e power px plus c3 e power minus px. That completes case 2. Next, case 3. Assume k negative. That means you can assume k equal to minus p square for some p. Is p negative positive? That is not a matter. So you get same equation with opposite sign. So you get d plus p square c square times t equal to 0, and here d square minus p square, okay, it will be plus, right, into x equal to 0. So auxiliary equation will be m plus p square c square equal to 0, and here m square plus p square equal to 0. So solving this, you will be getting m equal to minus p square c square one side, and here m equal to plus or minus ip. So here the solution is capital T equal to c1 e power minus p square c square t, and here capital X equal to real part is 0, so you get e power 0 into t, that is 1 cos, c2 cos px plus c3 sin px. Okay, now the required solution is capital, sorry, small u, right? So small u equal to c1 e power minus p square c square t times c2 cos px plus c3 sin px. So this completes case 3. So finally we got all possible solutions of equation, it equation, when k is 0 or positive or negative. So with this we completed the discussion of solution of it equation. Okay. So in the next video we shall discuss applications of PDE for the solution of Laplace equation.